Hello everybody, welcome to another video lesson. Today we're going to wrap up our chapter on rational functions. We're going to be looking at solving rational equations and inequalities. Forgot to turn my music off. Okay, so that is our objective for today. That's exactly what we're doing, solving rational equations and inequalities. Let's hop into our concept slides. Our definitions for our rational equations is really just an equation containing one or more rational expressions. All right, now to solve these, we want to multiply both sides by the LCD, or the least common denominator, in order to remove the fractions. Okay, so our first thing we want to think about is removing those fractions, and then we can go ahead and solve for the variable. Now, an important note is we always want to check our solutions, because with our rational expressions, we are going to have some domain restrictions. So we need to list those out as well and see if our solutions fall within those domain restrictions. So an example here is just 1 over x is equal to 4. That simple can be a rational equation. We also are going to take a look at rational inequalities. Okay, a few more steps that we need to take here. Again, we're going to state any domain restrictions, so any terms, any values that create a 0 in any of our denominators. And then we're going to solve the related equation. So we're going to turn our inequality into an equation and solve that. And then we need to create our number line and test the solutions for each interval on that number line. Okay, so an example here again would just be 1 over x is less than 4. Something that simple is considered a rational inequality. So let's take a look at a few examples now. We're going to solve our rational equation here. This is an easier one because we only have one term here with a variable in the denominator. So first thing we should do is just get all of our terms with our denominator, or with a variable on one side of our equation, and all of our terms without on the other side. So we're going to go ahead and subtract 3 over 2. It's going to give us 19 over 10 minus 3 over 2. Our least common denominator on the right-hand side is going to be 10, so we can multiply our 3 over 2 by 5 over 5. That gives us 19 over 10 minus 15 over 5. So 2 over x plus 3 is going to be equal to 4 over 10, which simplifies to 2 over 5. Okay, so this is the equation that we're working with now. We can go ahead and cross multiply. And when we do that, we can divide by 2. So 5 is going to be equal to x plus 3. We subtract 3 on each side and get that x is equal to 2. All right, so now think about my domain here. I cannot have a value, x cannot equal negative 3, right? X cannot equal negative 3 because that's going to create a 0 here in this denominator. If I set this x plus 3 cannot equal 0, then we get that x cannot equal negative 3, but 2 does not equal negative 3, so we're okay there for our solution. Let's take a look at another example. This time we're going to have multiple terms with our variable in them in our denominator, all right? And then we're going to have the variable in the numerator and the denominator for this example. So we're going to start off with the process of finding our least common denominator. So I'm going to go ahead and factor each one of my denominators. So I'll have 3 times n plus 1, I'll have 4 times n minus 1, and I'll have 2 times n plus 1. Now this 4 is actually, we can think of this as 2 times 2, right? So this is 2 times 2. I'll think of that instead of 4. All right, and that's going to help us simplify our least common denominator, which will just be 3 times that 4, which is 2 times 2, times n plus 1 times n minus 1. So our simplified LCD will be 12 times n minus 1 times n plus 1. So we can go ahead and rewrite our equation, and now we're going to multiply every term by our least common denominator. And when we do that, that should get rid of our fractions. So we can go ahead and start simplifying. Okay. So I'm going to be left with 4 times 7n times n minus 1 minus 3 times 5 times n plus 1 is equal to 6 times 3n times n minus 1. Now, if for some reason you get to this step and you still have fractions, then you've made a mistake with your LCD and you need to go back and take a look at that. Or you made a mistake with simplifying and maybe something else simplifies that you missed. But at this point, we should be getting rid of all of our fractions. So now we can go ahead and just solve this. So we'll start by distributing all of our terms. And then we can combine like terms from here, get everything onto one side. And here we actually have a scalar of 5 that we can factor out. So when we factor that out, we'll have 2n squared minus 5n minus 3 is equal to 0. And we can go ahead and use our crossroads method to factor that out. So we'll get factors of 2n plus 1 times n minus 3 is equal to 0. Set both of those equal to 0 and solve, and we get n is equal to -1 and n is equal to 3. Now here's where we have to check. Always remember to check. We're not done at this point. We have to take a look at our domain restrictions. Again, if I set my denominators not equal to 0 and solve for those, then I'll get x cannot equal 1 or -1. However, n being -1/2 and 3, that's neither of these values, so both of those check out, and those are going to be solutions for this equation. Okay, let's take a look at another example of rational equations. I'm going to pause, or you guys pause the video and see if you can solve this one. Keep in mind that we have a negative out in front of our this fraction here on the right-hand side of the equation. Okay, so pause the video and figure that out. Okay, hopefully you got no solution. When you solve this, you'll get z is equal to 1. However, that falls within our domain restrictions of x cannot equal, I guess that would be a z cannot equal 1 or -1. Okay, so with that being the case, then we have no solution here for this rational equation. All right, now let's take a look at some rational inequalities here. Okay, so first thing we want to do, again, let's list out any domain restriction. So x cannot equal 0 in this case. And then we can go ahead and find our LCD. So we have an LCD here of 15x. We're going to multiply each term by that 15x and then start simplifying. Again, that should get rid of all of our fractions. Okay, and then notice that we are working with the related equation. So I dropped the inequality sign and I brought in this equal sign. So now I am solving the related equation to this inequality. Okay? So when we do that, we're going to come up with a solution. So I'll have 93 is equal to 10x, divide by 10 on each side, and I get x is equal to 9.3. So now, don't forget, we are working with an inequality here, so we are not done with this. This is not the solution here. We should have a solution set, so x is less than or equal to some values. X is not just equal to 9.3. So at this point, what we want to do, we want to go ahead and set up our number line. Okay, and then we're just going to pick some values. So we have x is not equal to 0, so we can go ahead and kind of, if it helps you, put a little dotted line at each one of these. Okay, and then these are going to be the intervals that we need to test. All right, so I've got 0 and 9.3. So just pick some values in each one of these intervals. Just pick some easy values, whatever you can, and then just test those values with your inequality. So now let's take it back to the inequality, and I'll go ahead and plug in 10 first. So that's going to give me 5 over 10 plus 6 over 50 is greater than 2 over 3. So if we go ahead and work with that, our least common denominator will be 150, so that's going to be 75 plus 18 over 150. That is going to be, that is not going to be greater than 100 over 150, so that is going to be a false interval. Okay, that is not part of our solution set. Now we can go ahead and test 1. When I plug that in, I'll get 5 plus 6 over 5 is greater than 2/3. That is going to be a true statement, so that is going to be true. And when I plug in -1, I get a negative value is greater than 2 over 3. That is going to be false, so that interval will be false here. So now my final solution set is just wherever I have a true interval on my number line. Okay, so here it's going to be in between 0 and 9.3. That is my final solution. Okay. All right, so with that exact same process, you guys pause the video and see if you can't find the solution set for this inequality here on the right. Okay, when we set up our number line, we have true values on going opposite directions on our number line. So that's going to give us an OR statement. So x is less than 0 or x is greater than 15 for this one. Okay, last example, let's take a look at some applications here. All right, how much of a 60% fruit juice solution must Jason add to 15 milliliters of a drink that is 10% fruit juice to create a fruit punch that is 35% fruit juice? So here we have a mixture application, and when we have these applications, I think it's pretty easy to set up a table. Okay, so we have two rows here, one being the amount of juice, and then the second row being our total solution. So our original amount of juice, we had 10% with 15 milliliters, okay? And then we are adding this 65%, so 0.65, and we don't know how much we're adding, okay? Because it's how much of this fruit juice solution must we add. So we have an X here for the solution, for the amount of the solution, okay? And then our total solution starts off at 15 milliliters, and we're adding, again, an unknown number. So our final equations here, we have, or our final expressions, we have our 10% times our 15, and we are, again, adding a 65% of an unknown amount. And then the final total amount of fruit juice is going to be 15 milliliters plus, again, that's some unknown amount of milliliters. So for an equation like this, we can go ahead and set up a proportion. Okay, so we have the final percentage over 100 is going to be equal to the amount of juice over the total amount of punch or the total solution. Okay, so we are ending with a 35% fruit juice. So we have our final amount of juice over the total, or sorry, yeah, the final amount of solution over the total amount of the punch that we've made. So then we can go ahead and cross multiply once we get to here. And I'll have 35 times 15 plus x is equal to 100 times 1.5 plus 0.65x. We can go ahead and distribute our 100 through and start solving for x, and we'll get that x is equal to 12.5. So in the context of our answer, we are going to add 12.5 milliliters to this solution for the 35% fruit juice that we're looking for. Okay. I said that was the last example, but we actually have one more. We're going to use these concepts for a work application here. Okay, so we have Andy and Ethan, they mow lawns together. Andy can work alone and complete a certain job in a certain amount of time, that is 4.5 hours. And Ethan can complete a job alone in 3.7 hours. So that's kind of the efficiency that they're working at. How long does it take to complete the job when they work together? Okay, so really we need to take a look at each one of these as a rate. Okay, so Andy's rate is going to be one job per 4.5 hours. Okay, one job per 4.5 hours, and Ethan's rate is going to be one job per 3.7 hours. Okay, so the equation that we're going to set up is going to be Andy's rate plus Ethan's rate is going to give us some final new rate. We can go ahead, that final new rate is going to be one job per X amount of hours, which is what we're looking for. We're looking for how long does it take to complete the job when they work together. Okay, so we'll have 1 over 4.5 plus 1 over 3.7 is equal to 1 over X. Again, we're trying to find X. So our LCD here is going to be 4.5 times 3.7X. So that's what we're going to multiply each term by. Go ahead and start canceling out what we can. That should get rid of our fractions as well. So I'll have 3.7x plus 4.5x is equal to 16.65. Go ahead and combine like terms, divide by 8.2 to solve for x, and we will see that it will take them about 2 hours when they work together to complete that job. All right, those are all the examples we have for today, guys. Good luck with your practice.